Problem number 4. Look at the system of equations below. Which of these statements describes the graph of this system of equations? F, the same line. G, two parallel lines. H, two lines that intersect only at 1, 1. J, two lines that intersect only at 0, -2. To do this problem, we're going to take each equation and put it in slope-intercept form, which you will recall is y equal mx plus b. In other words, we're going to get y by itself for each equation. So in the first equation, to get y by itself, the first thing that I would do is subtract 12x from both sides. And I would get an equation that looks like that. Remember, to move something from one side of an equation to another, you do the opposite. Second, to get y by itself, I'm going to divide every term everywhere on both sides by -4. When I divide, the -4's divide out and I get y equal to -12 divided by -4 is +3. Again, I encourage you to do the arithmetic on your calculator. And +8 divided by -4 is -2. So that's the first equation with y by itself. To get y by itself in the second equation, it's a little bit easier because there's no coefficient other than -1 with the y. The first thing I'm going to do is to move the 3x to the other side by subtraction. So I get -y equal to -3x. Remember, I'm changing sides, so I'm changing signs, plus 2. Remember, I also want y by itself. I don't want -y, I want +y. So I'm going to divide every term everywhere on both sides by -1, and I'll get +y equal to +3x minus 2. So this is the second equation all by itself, and this is the first equation all by itself. What you notice when you look at these two equations is that they are exactly the same equation. So if they are the same equation, then they represent the same line. So we pick answer choice F.